Hello everyone, and welcome back to Knowledge Space. For all those Star Wars fans, you should know that Luke Skywalker destroys the second Death Star. But how much money would it cost to build a Death Star in our world, not in a galaxy far, far away? First of all, the Death Star is humongous. It's about 140 kilometers in diameter. The biggest machine that we humans have built is the Large Hadron Collider. It's only 27 kilometers long and took us about 30 years to build. The economics blog at Lehigh University made an estimate that a real-life Death Star would cost about $852 quadrillion just for the steel. To put that into contrast, that's roughly about 13,000 times the world's gross domestic product, or GDP. A Death Star will need the steel, which is made from molten iron. The Earth's crust has nowhere near enough for one star, but the core has so much it would be enough for not 1, but 2 million Death Stars. And at today's rate of steel production, it would take about 835,000 years to complete. Don't forget people. Assuming you pay everyone $100,000 a year, for 1.179 million people, according to the official Star Wars databank, the price is about $1.2 trillion. There are also 7293 TIE fighters on board. Let's assume TIE fighters used engines that cost about the price of a Lockheed Martin F-22 engine, which is about $150 million apiece. Just for engines, it would cost $1.09 trillion, just for engines. The closest thing we have to the ion cannons on board the Death Star is the antenna laser. Working at 60 kilowatts, it can disable a car. The makers say it can work up to 500 kilowatts. That's enough to disable a full airplane. One for $25 million. The Death Star has 2,600 of this, which is $65 billion. It also costs money to send things into outer space. This would make the cost of launching just the steel into space about $17 quintillion, as it costs $20,000 per kilogram or $40,092 per pound to launch just the steel into space. Another $1.2 trillion for the humans and the TIE fighters, which would weigh 1,800 kilograms, 3,900 pounds, would be $262 billion to lift. All in all, $17 quintillion and $852 quadrillion isn't worth it. Maybe in the future, though. And see you next time on Knowledge Space. Plus, don't forget to subscribe.